Everybody's here. All right, give me one sec, guys. You okay? I'm fine. Hello?
Yes, sir.
Yeah, just checking to make sure you can hear me fine. Yes?
Yes, sir. Yes, sir. I can hear you.
All right, one sec. Let me just get this sharing. Last class, the Maya asked me if I'd gotten the stuff posted on Canvas. I realized I think I'd missed three lectures, actually. So I got them all posted. Making
Yes,
sure
sir. I
you.
saw that.
Okay, good. All right, one sec. You can see my screen, right?
Yes, sir. I can see your screen.
Give me one sec. Okay. All right, so as we have on screen, what we're going to be looking at today is SIT steps or system integration testing steps, evaluation and data-driven methods. Continuation from last class, where we looked at how we can test the implementation after it's been executed, right? Um, we're going to be looking at those three things tonight or this evening. Um, yes, let me see now. One sec. After tonight, we should be finished with unit 5. Oh, and I guess one quick thing is to make sure that we're all on the same page where it relates to the assignment that we have due Friday. Just making sure that we remember that we have an assignment due Friday, yes? That
Yes,
is
sir.
assessment 2. Hopefully you guys been working on it.
Yes, sir.
All right, good. Um, in the event, or I guess since, well, no, let me not say it that way. I I posted an announcement on it, right? I think I did. Um, so I'm guessing that you guys would have seen it. I Since I don't see Romain in class, I can't confirm that he's seen it. But are you able to say whether or not he knows about it?
We're not sure.
All right, no problem. Not really your problem anyway, so if you don't, it's fine as well. Okay, so let's see. Let's see. It is going into that. All right. So last Friday we have covered which testing approach to use. That is Big Bang, top down, and so on. Those would be the strategies. Tonight, what we're going to be looking at is we're going to be covering the process. That's the actual steps that you follow when you're running a system integration steps. And we'll have 5 of those processes. Step 1 is when you create a test plan. Step 2, creating test cases and test data. Step 3 is executing the test cases. Step 4 is fixing bugs and then retesting. And then the final step is repeat the cycle until all components are successfully integrated. All right. In this case, it's very important to follow order. Order matters in this case. Right? And again, this is something that you want to pay close attention to. We're kind of in exam territory. Not to say that the rest of the content we haven't covered isn't exam territory, but we have different parts that are weighted differently. So you're going to want to focus on different units, or I guess put your focus on different parts of the exam, depending on the weighting. Or I guess if you want to be a good student and get builds on the whole thing, you put all the same effort on every part there, right? Mhm.
Yes, sir.
Okay, so we're gonna look at step one. Step one, where we create a test plan. So before you write a single test case, before you execute anything at all, you need a plan, right? A test plan is simply a document that lays out what you're going to be doing, what you're going to be doing to test, how you're going to test it, and also who's responsible for what, the timeline that you're going to need to implement these tests, and what the success criteria are, right? That last one is very important, where we would have talked about having measurable processes, knowing what the status of a project looks like before and also after. So we also need to have those success criteria laid out before and after our tests so that we know if our tests were actually successful, right? Most organizations, they use standard test integration plan templates. And the templates cover things like what modules are going to be in scope. So what systems are going to be affected by your test plan. Not your test plan, but your testing. Which test you're going to be using, what the test environment is, the required resources, the risks of the tests. Well, not even the risk of the test, the risk of the the integration itself, and also the entry and the exit criteria for each testing phase. So I'll tell you why this matters. Without a plan, testing is going to become chaotic. You're going to have people testing the same thing twice. You're going to have other things not being tested at all. And there's not going to be any way for you to track the process of the test. Sorry, not process, the progress of your tests. So a good test plan is considered foundation for everything else. Do you agree?
Yes, sir.
Friends? Mm-hmm. Okay, so that's step one. Step two is creating the test cases and the test data. So once you have a plan, you're going to translate it into specific executable tests. You can think of a test case as a specific scenario that you're going to run. So a test case has inputs and it has expected outputs, and it also has the steps required in order to execute it, right? I'll give you an example. When a customer places an order on your e-commerce webpage, the inventory system is supposed to decrement the stock um, by the order quantity, right? So if you have 10 items that you're going to buy, when you go on the website and you buy 10 items, the inventory stock is supposed to decrease the stock by 10, right? You can think of that as a test case. And you'd have dozens or even hundreds of these for a real integration because you want to make sure that your testing is robust and your planning is thorough, right? You basically think of all the different edge cases, or not just edge cases, sorry. Edge cases are like the outliers, basically. You want to think of all the different scenarios or just regular cases that your system can go through, and you want to test them thoroughly. Edge cases would come in the form of unexpected use cases where, like, maybe you have a case where somebody using a calculator, for example, and instead of typing in 2 plus 2, they type in 2 plus plus minus 2, right? That's not an expected way to use a calculator, but your system needs to be able to, or rather, your calculator needs to be able to account for something like that, right? So the people who build the calculator assume that people could potentially use the calculator that way because there's nothing stopping them from doing it that way. And they're able to give you the correct result depending on what the person punches into the calculator, right? So those will be edge cases. Right. So test data is information that you need to feed into the test. So like, for example, sample customers like, users, email addresses, first names, last names, addresses, if your system takes that stuff. Sample orders, so that you simulate what a user may order. Sample products, sample payments. All these things need to be like, it's like dummy data in your database, basically. Not just your database, but also data that will be fed into your system. Placeholding data or dummy data. And you need this data to be representative of a realistic scenario. I guess most of the data can be realistic, and then you can have data that includes edge cases as well. An edge case, so that example I gave a while ago would be like if somebody makes an attempt to buy -1 headphones or -100 headphones, what your system supposed to do? Should your system even allow that? Right? So it'd be like an edge case. A question you could ask yourself, in addition to that, what would happen if a customer orders 1,000 units? 1,000 units of an item, even though you don't have stock, right? So those would be similar edge cases that you'd need to make sure your system is able to account for. Also, what happens if the payment fails halfway through? So you accept payment and the payment process starts. And because payment is very often a multi-step process, what's going to happen if the payment stops halfway? Is the person going to get their money back? Is their person's money going to get stuck in limbo? Will their money make it over to the web page, or not the web page, the organization, and then the user don't get them stuff? Or if it's a case where the money is going to disappear, right? Those are things that you're going to need to test very thoroughly. Tell me if I'm making sense. Yes?
Yes, sir.
Yes, sir.
Okay. So, on to step 3, that was step 2. So step 3 is executing the test cases. So this is where you're actually going to run those tests against the integrated system now. And for each test case, you run it, you observe the result, and then you compare it to the actual expected output. If the actual output matches the expected output, then the test pass. But if they don't match, then the test fails. And then what you'll have to do in the event of a fail, well, regardless of whether you fail, you should just log everything. Take recordings of everything that happens. If it's a pass, then you log that it's a pass. And if it's a fail, you log the failure. One important thing when you're logging failures, it is not enough to just log that the test failed. What's also very important is for you to log everything that happened around the failure. So you take note of what the inputs were, you take note of what the output was, you take notes of what you did to perform the test, and you take note of everything that you believe that could potentially affect this particular scenario. Even if it's things that don't affect the scenario, record that too. So you'll record that today is Tuesday. You'll record that it was raining outside. You'll record that your mom made dinner tonight. You specify what dinner she made, every single thing about the scenario. You record everything. And that's important because when you hand that test over to somebody else, they need to know how to recreate it. So you need to have the person use the same inputs as you in the same way that you use them. And if it is a case where the results are dependent on those all those inputs and all those circumstances, then they should be able to recreate the scenario. And hopefully they'll be able to fix the issue, fix the test based on the circumstances of the scenario. Right? So execution is not just clicking the run button, or it's not just clicking go, right? You need to document what happened. You need to document which tests passed. You need to document what failed. And you need to also document the actual output versus the expected output. And as I said, very important for you to specify all the things around the test, what environment you ran. And this documentation is going to become very critical. Okay. Very critical for this particular step, fixing bugs and retesting. Okay, so that's step 4, fixing bugs and retesting code. So when a test fails, the developers are going to investigate. They're going to find the root causes and then they're going to fix it. And then after they do that, they're going to run the test again and then confirm if it worked. It all must work, Yeah. So that's the point of running the test again and checking to see if it actually going to work. But here is something to look out for. Fixing one bug could very easily introduce another bug. And I'm sure you guys have seen that in the past.
Yes,
And
sir.
this is come again in coding, yeah?
Yes, sir.
Yeah, man. So everybody that writes code is supposed to be familiar with that. So
Sometimes it's better to leave a previous bug.
say it again, please.
I said it's sometimes it's better to leave a previous bug. Like you're trying
Oh,
to
you said
fix
this.
a bug and it create more bugs and it's better to leave that first bug.
Yeah, just make it stay down. Okay, not trouble nobody.
Yeah.
I agree. Sometimes. But yeah. So fixing one bug can introduce another one, right? And this is called regression. So when you fix a bug, you don't just retest that specific case. You also have to rerun related tests to make sure that the fix didn't break something else, right? And this is also where this is also where defect tracking becomes essential. So you need a system, usually like a tool, like for example, Jira or Bugzilla, that tracks every defect from discovery through to fixing, that tracks every defect from discovery through verification. So you have the 3 steps: discovery, fixing, and then verification, right? And without defect tracking, bugs are just going to fall through the cracks. So like you will discover bugs, and if you don't track them, you can potentially like keeping them in memory. When I say keeping them in memory, I just mean like you just noting a bug or for yourself personally. And when you go to fix them, you won't be able to remember which were bugs or if a bug was fixed, or if you tend to fix a bug that seemingly fixed another bug, when it actually didn't fix that bug, you're going to find that that bug could probably come up back later. So it's a good thing to track your bugs, track everything, and test and retest. You guys familiar with Jira? Have you ever used Jira before?
Repeat, sir.
Jira, Jira, Jira.
No, sir.
First time I'm hearing about it.
Okay. Well, when you guys graduate, I should say, and you go into the working world, if you stay in the field of IT and programming, you will almost certainly hear about Jira. That is if Jira doesn't get like run to the ground by the time you get into the working world. But Jira is a really good tool. I use it all the time for like keeping track of your progress of like just tasks that you do. So like you can have a board that has different columns. You have a to-do column, you have an in-progress column, and then you have a done column. And you can have multiple other columns that you want to keep track of as well. And you basically write down tasks, and you can link tasks to other tasks. You can write subtasks and all that stuff. You can write descriptions on the tasks. And it's a good way to keep track of all the things that you do. So it's a tool that is used very often in the world of IT and otherwise. You don't even have to use it alone in IT. But it's a good way to keep track of your working tasks if you need something like that. Right? Where am I? So yeah. Oh, I am here. Step 5. We repeat until integration, or until integrated rather. Repeat the cycle until all components have been successfully integrated. Testing integration is not a one and done. It's something that you iterate through. So you do one thing, you fix it if it needs fixing, and then you test, and then you do it all again. Repeat, rinse and repeat, right? So you run tests, you find bugs, you fix the bugs, then you test again. Then you find more bugs, then you fix those bugs, then you retest, right? Eventually, all the tests that you run, they become stable, all the bugs are fixed, and integration passes, and the exit criteria defined in the plan. And the exit criteria passes the exit criteria defined in the plan. Meaning, typically what you do for your plan is you define what you would need to observe in order for you to know that all your tests pass or your integration is complete. And that may come in the form of all tests passing. So if you make your test plan and you find your bugs and you fix them, and you keep iterating through and through until all of your tests pass, then that essentially means that your integration is complete. And that's how you know you're done. So you may ask, how long is this going to take, right? And obviously, like the answer to a lot of questions, that's going to depend on the size and the complexity of the integration project. For a small system, that could potentially take a week or two, I guess depending on how small the project is. But for like a large enterprise integration, that could take months. It could even take years. I really hope it doesn't take years. But the key is persistence, right? It's not good to declare victory until every single component is genuinely working together, right? Okay. Tell me, we're good with that? That sounds solid?
Yes, sir.
Okay. This sounds like a relatively simple topic so far, but it's good stuff for us to keep in mind. Easy topic meaning it can be easy to study, right? Okay, so that's a SIT process, the system integration testing process. So now what we're going to be talking about is evaluation. Specifically, how you evaluate whether the integrated systems interface actually works well for users. So we're going to be looking at 4 main techniques, right? 4 techniques that you can use to know if your system integration interface is actually working for all users. And those may come in the form of questionnaires for user feedback, video recording, and tape evaluation. Tape, that's crazy. Verification and validation. We're going to go through each one of them. You guys ever heard of UAT or user acceptance testing?
It sounds familiar, sir.
Sounds familiar. Okay, what about QA or quality assurance?
Yeah, I've heard about quality assurance.
So that is the testing side. Is it the testing side? I guess the both of them are 2 different levels of testing. So it's not enough to just build your applications or your systems. You have to also test and make sure that they are what the user actually wants. So you have to test for a certain level of quality, and then you have to test to make sure that the product or the system that you're building is to the level that the user that's going to be using it actually wants it. So that's QA and UAT. All right. So yeah, I made mention of those 4 techniques. So we're going to go through each one of them one by one. So the first one, questionnaires for user feedback. So in a case like this, you will have real users that you're going to expect to be using the application, representatives of the application. You give them a structured set of questions about the interface after they've used it. So you'll ask questions, for example, how easy was it to navigate? How quickly did you complete the task? Or where did you get stuck? What confused you, if anything confused you, right? So this approach, this technique of using questionnaires, it's relatively cheap. I guess it's as, I was going to say that it's as cheap as the paper you print them on, but we don't use paper anymore. We use Google Forms, right? So it's cheap to issue. It's very scalable, and it helps to produce quantifiable data. Quantifiable meaning you're able to assign a number to the data, right? So like if you have 9 out of 10 users say that the checkout button was hard to find, then that's a clear signal, right? 9 out of 10 people believe that it is difficult to find. You can run questionnaires on dozens or even hundreds of users. And that's valuable because there's some techniques that you won't be able to actually issue a large number of or get as much feedback as that for like a large group of people, right? But the limitation in this case is that users don't always know what confuses them. Some people would rationalize their experience after the fact. They'll say stuff like, oh yeah, it was fine, even though they struggled. Because, either they don't want to seem stupid or maybe they just think that under normal circumstances, the difficulty that they had was their own fault. They don't know that the issue that they were actually having was a fault of the UI itself or the system itself, right? So questionnaires are they're very useful when combined with other techniques. It's not something that you use by itself. Okay. So that's questionnaires. Next one we're going to be looking at is video recording. So we use video recording of system use. So like basically like a what do you call that again? A screen recording of an application being used. You could record the user interacting with the system. You could have like I said, a screen recording or like a face cam, basically to get their expression of how they think they are going with the application. And then the design team would take that recording and they'd use that to identify usability issues. Even if it's a case where you give the users a questionnaire and you ask them certain targeted questions, the answers they give you may not actually be in line with their actual experience. So like I said, somebody may think that what they have is a problem that is their own fault, but when you look at their behavior in real time in the video, you can see how their actual experience with the system or the product was. So having a video recording or being able to observe the user while they use the application is also very useful. Yeah. So yeah, it's very powerful because you get to see what the users actually do and not what they say, right? You get to see stuff like the hesitation. You get to see how they misclick. You get to see when they get confused and what's happening on screen when they're confused. And you can actually get to also time how long they take to perform a task. You get to identify patterns across multiple users, right? In a case like this, a limitation could potentially be cost. And when I say cost, I don't just mean in money. I'm talking about in time. Because doing video analysis is very, very time consuming. Reviewing a 30-minute session is going to take minimum 30 minutes, right? I guess unless you speed up the video. But then if you speed up the video, you may lose certain information. So a 30-minute video can take minimum 30 minutes to analyze. And it could even take longer, especially if you're taking notes and if you're, rewinding and pulling back to make sure you never miss anything. Also, it's very important for you it's also very important for you to get user consent. Yeah. But for high stakes interfaces, I would say that this is one of the most valuable techniques available. Right? So that's technique 2. We're going to be looking at 3 and 4. That kind of go hand in hand, verification and validation. Right? So this one is pretty easy to mix up. So I'm going to see if I can put them side by side. Maybe we can consider them to be one technique, but we'll see. So verification. When I talk about verification, the question you should think about is, did we build the system correctly? So it's about conformance to specifications, right? If the requirement says the login form must have a username field, a password field, and a submit button, then the verification checks will make sure that all 3 things are present and functioning as specified, right? So it's a quality check against the written requirements. Validation, however, will ask a different question. It will ask, did we build the right system? Yeah. Verification was, did we build the system correctly? But validation is, did we build the right system? So that's now about meeting with the user's actual needs, making sure that we built what the user actually said that they wanted. The login form could match the specifications perfectly, but then validation is going to ask whether the form actually solves the user's real world problems. So you could have a login form and it would have all of the different components, the username field, the password field, and the submit button. But what if the user never wanted that in the first place? I lost my footing 1 sec. Even if the blah, blah, blah. Right. So maybe the spec said username, but the users actually wanted to log in with an email, right? The verification itself would pass, but this and because the specs would be met, but the validation would fail because you have the components, but it's not what the user wanted. So one of the easy ways to remember the distinction between the two, verification and validation, is verification says you built the thing right, but validation, verification is you built the thing right, but validation is if you built the right thing, right? Similar but different. So the exact distinction is tested in the multiple choice section of an assessment that's going to be coming up. So it's good for you to memorize that. So that's something that you should take note of, the difference between verification and validation. That good? Was that clear? Or was that confusing? You guys good on that? The difference between
That's
verification and validation? Yeah. Okay. Don't mind that good?
Yes, sir.
Okay. So you can take that as a pointer to note. Okay, where's the next thing? Right, okay. So now we're at integration layers. Wait, did I lose myself? Hold on. Oh, okay, my mistake. Okay. So that's the second topic that we just covered a while ago. Another topic that we need to look at is the data-driven methods across 3 layers of an integrated system. Data-driven methods across the 3 layers of an integrated system. Okay, so when you're testing an integration, you're going to have data flowing through multiple layers. Each layer, the data is going to have a particular state. And when I say state, what I mean is the condition that the data is, the state is a condition that the data itself is in. So if something goes wrong at any particular layer, then the data integrity is going to break down. So the data-driven testing method, that's going to examine the data state at 3 specific layers. The 3 layers are the integration layer, the database layer, and the application layer. For this part, you can think of it like, you guys did math, right? When you are working out a specific problem, for example, do I even want to say? Yeah, quadratic formula. You guys remember the quadratic formula from CSEC maths days? Yes? No?
kind of, sir.
All right, let's not use the quadratic formula then. Let's use something simpler. What's simpler? Y'all know how to calculate the area of a triangle? Yes?
The area.
Mm-hmm.
I think so.
Mm-hmm. Remind me of the formula for the area of a triangle, please. Google it if you need to. Has it been that long since you guys did math? Why do I remember to calculate the area of a triangle?
Base times height.
Say it again.
Base times height.
You sure?
Squared half. Half the
Half base times height. Good. Yes.
yeah.
So think of that formula as like a multi-step formula that has different layers. First, you take the half, then you multiply it by the base, then you multiply it by the height. If for some reason, at some part of the process that you're doing, let's say, for instance, one of your values were 3.576. And when you perform the multiplication on the half, instead of keeping all your decimal points, you cut off all your decimal points and you just multiply it half by 3. Then your data is going to be not wrong, but it's going to be less accurate, right? And because it's going to be less accurate, that data that you're going to be using in the next step is going to be affected, or rather, the next step is going to be affected by your inaccurate data. And the more steps you have, the less accurate your data on the very end of the process is going to be, right? So I was using the half base times height example to show that if you were to, for example, get a value that had a lot of decimal places, and you chose to round down or round up for whatever reason, then the next step that you take in the half base times height formula is going to be affected by your rounding down or rounding up. Make sense?
Yes, sir.
Okay. So the three layers that I said we're going to be looking at, the integration layer, the database layer, and also the application layer. Okay. So I'm going to be using a concrete example. The example I'm going to be using to relate this information is a retail system. A retail system that's integrating a point of sale system, inventory system, and e-commerce system. A scenario that we are all very much used to. Okay. So integration layer. This is where the data passes between the systems. The integration layer is the middleware, the APIs, the message queues, and the connectors. Whatever moves data from system A to system B, right? That's what we consider the integration layer. So at this layer, you verify that data passes correctly between the systems. Looking at a retail example, when you have a sale that happens at the POS, does the integration layer correctly transmit the sale data from the inventory system over to the e-commerce platform? Does it arrive intact? Does it arrive on time? When it arrives, is it formatted correctly? Right? So those are questions that you'd ask when you want to be confirming the integrity of your integration layer. Some of the common issues at this layer is data format mismatching or dropped messages, timing issues, or transformation errors, where the data would get potentially corrupt as it moves between the systems, right? So that is integration layer. You want to make sure that that layer is very solid before it moves on to the next layer, because as I said, the more losses we have, the more errors we experience, is the less accurate the data will be when it goes on to the next stage or to the next step. So that is the integration layer. Next, we're going to be looking at the database layer. So this is where the data is going to live at rest. It's where the data is going to be stored indefinitely. So each system should have its own database, and the data is going to be stored there. The data stored in the database needs to maintain integrity across the integration, right? So at this layer, you're going to verify data integrity in the underlying database. So this means you don't want to have any orphaned records. So when I say orphaned records, what I mean is every child record or every related record has a valid parent, or every record that is dependent on something, the dependency is in fact present. You don't want to have any records in your database that are supposed to be dependent on something, and when you look to see what it is dependent on, the dependency is missing. Have you guys done relational databases? Is what I'm saying make sense? Can you relate it to stuff that you've done before? Just want to make sure.
Yes, sir. We have done database management,
Okay,
Yes, sir.
so
so
we kind of get the idea what you're talking about.
okay, good. So like for example, let me still give an solid example. Okay, so a product payment. A product payment cannot exist without a user, right? Because users make payments. So you might have a database table that stores a list of users, and you're going to have a list of another database or another table that stores a list of product payments. A product payment will have different things. It will have the product itself, it will have the time that it was purchased, and it will have the user that purchased it. So when you look in the product payment table, you should see a list of users, or you should list a list of user IDs, right? If you have a product payment that's related to a user that made that payment, and that user's payment ID or that user's user ID is ID2, it means then that you should be able to go into the user table, look for a user that has an ID of 2, and that user should be present. If it is a case where you look to see if that user is no longer present, then it means that that product payment may no longer be relevant. It might still be relevant, I guess, depending on the system. If it's a case where you want to be able to keep track of payments, past payments, regardless of whether the user is still on the system, then you probably want to keep it. But in a different scenario where you have one record that is dependent or associated with another, and that parent record is no longer present, then you have an orphaned record. Yeah. Okay. So let me see. Yeah, so that's orphaned records. You also want to make sure that you have, and I'm sure that you guys will be familiar with this, you have correct foreign key relationships. Yeah. Um, I would imagine that you're also familiar with foreign keys, right?
Yes, sir.
Yes, sir.
Very good. So
Foreign key and the primary key.
correct, yeah. Good. So we want to make sure we don't have any orphaned records. We want to make sure we don't have any uh, mismatched foreign key relationships. And we want to make sure that we have consistent data across the systems. An example of that would be like if system A stores customer IDs as a number, then it means that system B, if system B gets that number, or rather if system B is expecting a number for the user and system A actually sends over a string, then you know that would be a problem, right? You want to make sure that the format between each system or the formats that are being sent are the same formats that are being expected. You wouldn't want to send over a number when one system is expecting a string. Yeah. Okay. Where am I? Right. Okay. So a common issue at this level is broken referential integrity, duplicate records, inconsistent data types, and stale data, data that doesn't exist anymore or doesn't need to exist anymore, data that should have been updated but wasn't, right? Okay. So yeah, that's the database layer. Have you ever heard the term dirty data? Like you may have a database that is filled with data that is not actually valid, stuff that should have been updated or stuff that's related to other data that doesn't actually exist anymore.
I haven't heard that term before.
Okay. Well, that's something that I've been exposed to quite a bit while I was working at NCB. We have databases. Well, I mean, as long as the databases aren't in production, it's more or less fine, but it makes testing very difficult. Difficult because, let's say, for instance, we want to build out a new application that's going to be dependent on some database information. Ideally, what you'd want to do is you'd want to test your newly created application against a real-life replica of the database that is being used in the production version of the application. Now, instead of using a replica, it may be easy for you to just use the actual product-facing, or rather public-facing database. But that's dangerous because if your application has any bugs in it, or accidentally, let me not say accidentally, if your application has bugs or it has logic in it that performs unexpected behavior, for example, deleting your entire database, that's not something you'd want to risk testing in production. You'd want to do those tests in a replica of production instead. So you make a copy of production and you isolate that database and then you run your test against that database, right? Now, because that database may be used for testing and the testing may be done by multiple people with different applications, you may find that people will take that database for granted. And you could find that you have a case where maybe the application needed to have the database work in a certain way for their application to work properly. So somebody went into the database manually and did some changes. They changed a 1 to a 0, or they updated somebody's address to have more than 50 characters in it, or they changed somebody's name from John to Jim, right? Going into the database manually and changing stuff just to suit you could lead to dirty data. And it can affect some of your applications depending on what your application needs. So that's an example of what I meant when I said dirty data, right? So that's on the database level. Okay, application layer now. So that's a third layer, the application layer. And the application layer is what the user actually sees. Each application processes the integrated data and it presents the data to the user through its own interface. All right? At this layer, you're going to verify that each application correctly processes and displays the integrated data as expected. For the retail example, you'd ask a question that says, does the e-commerce website show accurate real-time stock levels based on the database system? Not the database, the inventory system, sorry. Or looking at the POS, does the POS receipt actually match the billing record? Or a question about the inventory dashboard is, does it actually reflect the latest sales? Okay. So we're talking about what data is actually visible to the user that's going to be using them. Is it actually appropriate or is it accurate information? And you're going to have limitations or common issues at this layer as well, where you have stuff like display bugs. You could also have an error. Wait, guys, give me 1 sec. Sorry about that, guys. Right, so what I was saying, you have common issues at this layer. Common issues would involve display bugs, meaning like you're supposed to be printing one thing, but because of an issue further downstream, you may have the data being presented or displayed incorrectly. You could have also a caching issue or a caching problem. When I say cache, what I mean is C-A-C-H-I-N-G. You guys familiar with caching or cache? It's like a temporary memory.
Yes, sir. I know about cache.
So a caching issue could come in the form of potentially the app displaying old or outdated data, even though the database actually has the up-to-date information. Maybe there is a step somewhere in the integration or somewhere in the platform that doesn't actually query the database for some information because of caching, right? It would just return the most recent version of that data instead of actually querying the database for that data, which could be a problem. And you also have processing errors where the app receives correct data, but when it's going to calculate or process it, the calculation is actually done incorrectly. So it displays the wrong value. Yeah. So the key insight to take away from these integration layers, integration can fail at any one of these 3 layers. And the symptoms are going to look different depending on where the failure actually occurs. If the failure occurs at the e-commerce site, it could look like it's showing the wrong stock count. And if it shows the wrong stock count, then you're going to ask yourself, where's the problem? The problem could be at the integration layer, where a sale probably never got transmitted over from one system to another. It could be a database layer, where the transmission arrived, but the database write failed. Like it got to the database, but when it actually tried to insert it into the database, the insertion actually failed. Or it could happen at the application layer, where the data is actually correct in the database, but the app actually cached an old value. So it never got updated on the application, the interface level or the application level itself. Right? So it looks different depending on where the error takes place. And the layered thinking is what separates good integration testing from superficial testing. Very important. Yeah. Questions? How we stay?
None
Good?
yet, sir.
None
Good.
yet. All right. All right. I think it should be okay for us to call it here then. So like I said, this is going to be a short session, and this is the end of that unit. So we're going to move on to the next unit. Let me see. So unit 5 is finished. Friday, we're going to start unit 6, which is commercial off-the-shelf products. That's that's the last unit? That might be the last unit. So yeah, we're going to move on to unit 6 and that may be the last unit. And then after we move on to that unit, we're going to do some exam preparation. Yeah. Okay, yeah. So once again, remember that we have an assessment due Friday coming up at midnight. So don't forget. No questions? We're good with that? Content was clear. Anything you guys want me to go over? Or was that clear?
Clear, sir.
Am I good?
Yes, sir.
Okay, just making sure. All right, cool. So we can call it there for tonight. That should be it. All right. Take care,
Yes,
guys.
sir. Take care.
Mhm.
Yes, sir.